everyone, welcome to video lecture on heat transfer. Myself Khushbu Shah, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In today's session, we will see some of the examples based on our last session theory. In our last session, we have seen how to calculate heat transfer coefficient in case of laminar flow and turbulent flow. In that, we have studied two empirical equations. If the type of flow is laminar, we have to use Sidertate equation, and if type of flow is turbulent, we have to use Titus-Boelter equation. Let's see, this is the statement of the example. Estimate the average value of convective film coefficient on inside surface of 50 mm inside diameter meant for heating water. So we have to calculate the heat transfer coefficient H for the pipe which is of 50 mm inside diameter and which is meant for heating water. This sentence is very important. It is meant for heating water. That means the purpose of this transfer process is to heat the water. The mass flow rate of water is given 25,000 kg per hour, which enters at temperature 293 Kelvin and leaves at 333 Kelvin. Calculate also the heat transferred per unit length of the tube if wall temperature is 10 Kelvin above the bulk temperature of the fluid. So in this we have to calculate two things. First we have to calculate heat transfer coefficient H, and second we have to calculate the heat transfer per unit length, that is capital Q by L. Right? Physical properties of the fluid at mean temperature. As I have already told you that in such type of calculation we always consider the average temperature of the fluid. We do not consider the maximum temperature of the fluid. So the property data are also given at mean temperature, that is average temperature of the fluid. The data given was density 992.2 kg per meter cube, thermal conductivity 0.634 watt per meter Kelvin, kinematic viscosity which is mu by rho which is equal to 0.659 into 10 raised to minus 6 meter square per second, and Prandtl number is equal to 4.31. So these are the data which was given in the example, and we have to calculate two things: heat transfer coefficient H and heat transferred per unit length, that is capital Q by L. These two value we have to calculate. So for first we have to calculate H, that is film coefficient value. For calculating film coefficient value, first thing is to calculate the NRE value, from which you came to know that what is the type of flow and what equation you have to use. Right? So in solution, first we have to calculate the Reynolds number. What is the value of Reynolds number? du rho by mu. Right? So in this we have value of d diameter. We do not have value of u. Velocity is not given directly, but you have the value of mass flow rate and density. So by using the value of mass flow rate and density, you can calculate the velocity. So first of all you have to calculate velocity. From velocity you can calculate the Reynolds number. So see here, mass flow rate of water is given 25,000 kg per hour. Density of water is given 992.2 kg per meter cube. So first we have to calculate volumetric flow rate. What is volumetric flow rate? Mass flow rate divided by density, that is 25,000 divided by 992.2. So you will get 25.2 meter cube per hour. From volumetric flow rate we can calculate velocity. See, as the diameter of the tube is given 50 mm, which is 0.050 meter. So now what is velocity of water? Velocity of water U is equal to volumetric flow rate divided by area. So here see, volumetric flow rate divided by 3600 to convert it from hour to second, and divide by area, that is pi by 4 d square. So when you solve these, you will get the value of velocity as 3.56 meter per second. Right. So now I have the value of velocity. So now I can calculate Reynolds number. What is Reynolds number? du rho by mu. But here, if you see, we do not have value of viscosity, but we have the value of kinematic viscosity. And what is kinematic viscosity? Kinematic viscosity is dynamic viscosity divided by density. So du rho by mu, in place of that we have to use d into u divided by kinematic viscosity, as mu upon rho is kinematic viscosity. So nr is what now? nr is equal to d into u divided by mu upon rho, which is kinematic viscosity, and here we have the value of kinematic viscosity. So now what is nre? nre is equal to d into u divided by kinematic viscosity. What is d? 0.05 into u. At velocity we have calculated 3.56 divided by kinematic viscosity, which is given 0.659 into 10 raised to minus 6. So when you calculate this, the value of nre is what? 270106. As this value is greater than 4000, the type of flow is what? Type of flow is turbulent, as the value of nre is 270106. Right? So as the value of nre is turbulent, which equation we have to use? We have to use the Ditters-Boelter equation. Right? As the flow is turbulent, we have to use Ditters-Boelter equation. Right? As nre is greater than 10,000, flow is turbulent region for heat transfer. As the flow is turbulent, we have to go for Ditters-Boelter equation. What is Ditters-Boelter equation? Nu is equal to 0.023 nre raised to 0.8 npr raised to n, if you remember that. And n is what? 0.4 for heating and 0.3 for cooling. Right? In the statement given that the system is meant for heating water, I have told you that this sentence is very important. The system is meant for heating water. That means the purpose of this system is to heat the water. And as we are heating the water, value of n is 0.4. Right? Here Pr raised to n. See here. Here Pr raised to n. But n is 0.4 for heating. So now my final Ditters-Boelter equation is what? Hi into di by k is equal to 0.023 nre raised to 0.8 npr raised to 0.4. Putting the value, we have to calculate hi. So hi as it is, di is 0.05 divided by k value is 0.634, which is given in the data, which is equal to 0.023 nre, which we have calculated 270106 raised to 0.8. PR value is directly given in the example statement. If it is not given, you have to separately calculate it first. Right? But here the PR value is given, which is 4.31 raised to 0.4. So in the whole equation, the unknown value is hi. So when you solve this in calculator, you will get hi is equal to 11584 watt per meter square Kelvin. Right? So this is our first answer. Film coefficient. Film coefficient, that is heat transfer coefficient, is equal to 11584 watt per meter square Kelvin. Right? Now the second value, which is asked, that calculate the rate of heat transferred per unit length, that is capital Q by N. Right? So heat transfer per unit length is Hi into A into T. Our basic law of convection, Q is equal to Hi delta T. Right? So Q is equal to Hi delta T. Here is what? Pi dl. But here per unit length, so L we have taken on the another side of the equation. So Q by L is equal to H into pi into D into delta T. Again I am repeating. Q is equal to H delta T. A is equal to pi dl. As L is per unit length, that is L is 1. So I have taken L on the another side, that is Q by L. So Q by L is equal to H into pi D into delta T. Delta T given in the statement, T1 and T2 was given in the statement. So putting that value, right? But when it is asked that calculate heat transfer per unit length of the tube, for that case delta T is directly given. Delta T is what? 10 Kelvin, as the wall is the temperature of 10 Kelvin above the bulk temperature of the fluid. So here delta T value is directly given in the statement, which is 10 Kelvin. Right? So putting this value, Q by L is equal to H into pi into D into delta T. H we have calculated already, 11584 into pi into D is 0.05 into delta T. Delta T directly given, which is 10 Kelvin. So Q by L is equal to 11584 into pi into 0.05 into 10. When you solve this, Q by L is equal to 18196 watt per meter. As it is asked heat transfer per unit length, that's why we have written unit watt per meter. If it is asked that calculate rate of heat transfer, then we have written the unit watt. Right? So this is our second answer, rate of heat transfer per unit length. So as we have to calculate the film coefficient and rate of heat transfer per unit length. So by this way we can solve the example of convection. Right? The steps to solve the example is same in all the types of numerical. First calculate NRE. From that you will come to know what is the type of flow. Second, as the type of flow is known, laminar or turbulent, you have to go for the Sider-Tate equation or Dietz-Boelter equation. From that you will calculate the value of H, heat transfer coefficient. And the last and third step, if it is asked to calculate rate of heat transfer Q, then you have to use equation Q is equal to HA delta T. These are the three simple steps you have to follow in any type of the examples of chapter convection. So remember these three steps. In any type of example you can solve easily, but then you have to follow these three steps only. Right? So I am completing this session here. I hope the numerical is clear to all. Thank you.